Okay, Year 10. We're up to the last graph that we have to do, and this is the trigonometric functions. Now, trigonometric operations, the same way that we did log and exponential functions in the last session, is just an operation you can do to number. You're finding the sine of an angle, or you're finding the inverse sine of a ratio. So, for example, you can go sine 20 on your calculator and it'll give you a value, sine 20, and you get an answer. I just better check that my calculator is in degrees. So I'm just going to check that. All right, so my calculator's in degrees, and there's my value for sine 20. So if I'm drawing a graph of y equals sine x, like any function, remember, you can just plot points, which is what we're going to do for the first one. So we're going to find the sine of these values. So first of all, sine 0. So sine 0. And sine 0 is 0. So what you do is we're just going to write these values in here. Sine 0 is 0. Next one, sine 30.5. 0, I'm going to make this a bit bigger, 0.5. Sine 60. 0.87. 0.87. Sine 90. And you just keep going through these. 1. Sine 120. Oh, look at that. It's the same as sine 60. That's interesting. 0.87. Sine 150. Isn't that interesting? It's the same as sine 30. Look at these values. What do you notice? 0.5, 0.5, 0.87, 0.87, 1. Well, let's go make a prediction about what that will be. You think about that. And I'm going to do it now. Sine 180. And it's 0. And look at the very first one. So it's like we've gone up the hill and come back down the hill. Let's see what happens when we do sine 210. Oh, it's 0.5, but it's a negative. Negative 0.5. Sine 240. Oh, negative 0.87. We'll see if you can make a prediction about what that will be. And see if you're right. Sine 270. I wonder if you predicted that it would be negative 1. And then see if you can make predictions about these ones. And let's see if you're right. Sine 300. Sine 330. I don't need my calculator anymore. Sine 360. Now I'm not going to do the last two because I'm going to graph this now. So I'm just going to plot some points. So I've got that point. 60 was 0.87. So let's zoom in a bit here. 0.6, 0.7, 0.8, 60, 0.87. There. Sine 0 was there. 180, 0. What were the other zeros? Oh, 360. And 210, It's 0.5, 0.87 for 240, 1, there. So now, if I join those dots, and this is going to be hard, so what do you think is going to happen as I keep going? Do you think something like this? And if you do, you would be correct. I'm just going to do it for where we went to. So we need to go to 390, which will be a half, and 420, which will be 0.87. So I'm just going to go to where we had our points. But I know at 450, it's going to be 1. And this is a trig function. And we say that this curve has a period. Now, a period just means a set of time, or a set for which it repeats itself. And it repeats itself every 360. So we get another complete graph by the time we got to 720. So that's what it would look like. So there's the first one. Now I want you to do cos, and you'll do it the same way. So go and have a go, do it the same way. So pause this, put all the points in on your calculator, off you go. Hopefully you've paused it, you've come back, and you've gone, 1, 0.5, 0.87, 0. And you're going to get those same values all the way along. So what you're going to get, I've got to hit 90. I'm going to zoom in a bit because I want to hit 90. So I'm going to hit 90. 180 will be 1, negative. 270 will be 0, and 360 will be 1. So it's going to go like this. Oh, that's really bad. I'm going to get rid of that. I'll try it again. Because it's a real curve. Sort of looks like that. I'm going to rub that out and do it again because it's not very accurate, but it's coming down. That's a bit better, except it should go through 270. And it had come back down and it had hit here. It had hit 0 again after 90 of 360. So 450, it's going to hit 0. So it would come down to there. And again, this one has a period of 360. It starts repeating itself after 360. And there's your cos curve. Now, you can check this by going to Desmos. So we'll type in Desmos and we'll type y equals sin x. There you can see. And unfortunately, it doesn't have degrees on the x-axis. It has a thing called radians. It has a value that is equal to the radius, the number of radiuses that can fit in 360, which is 2 pi. But it does go up and down to 1 on the y value. Now, if I type in cos, and have a look at that, it's a blue curve. And you can see it goes from from up here, it repeats itself about this many times. And you can see the curve, it's just going to repeat. They actually use this for sine radio waves, and it's very good for what we call simple harmonic motion. So let's go back. Let's now explore tan x. Okay, so again, this one's going to be a little bit different, so off we go. tan 0, tan 0, 0. So again, I'm just going to write them in. Tan 30, 0.57, 0.58. 60, 1.73. Is it 1.73, 1.74? 1.73. 90. Uh-oh, an error. Yeah, this is where we get something that's called undefined. And undefined, I'm going to use that symbol. I know it's an infinity symbol, but it's undefined. Tan 120. Oh, it's a negative 1.73. Tan 150. Oh, negative 0.58. So what do you reckon tan 80? You see me make a prediction about tan 180. Let's see if you're right. Yep. So it's coming back. Tan 210. 0.5. Oh, so now we're getting the same values. Well, let's make some predictions here. 0.58. I bet that is 1.73. I bet that's another undefined. Let's try that. Tan 270. All right. Now, so it was positive, negative, positive. Wonder what it'll be here. Tan 300. Now, what do you think? Should be 0.5. What do you reckon? It's at negative again, so it's gone back down. Negative 1.73. What do you reckon? 330. Tan 330. Yes, as I suspected, and possibly you did, negative 0.58, which means that'll be 0. All right, well, I'm going to stop there, even though I've got the other ones. So now if I plot them, so what have I got? I've got 0. I've got 0.58. So for 30, so about there. 60, I've got 1.73. Well, it's sort of off the chart. Yeah. And then I've got this infinity symbol, or undefined. What I'm going to do is I'm going to draw in a special thing here at 90, and I'm going to dot it. And this is called, and we've already discussed it, a limit which the graph is going to approach, and hence we call it an asymptote. It cannot touch it. And we know there's another one of those at 270. Look over here. So at 270, we've got the same thing happening. So we'll put that in. All right. So our graph is going, oh, geez. Got to make it really steep to hit that point. Come on. Up like that. And it's doing the same. It's going to go through 0 here. I'm not going to plot the other points because I want to get a nice smooth sketch. And it's going to go like that. And then we know it hits 360 at 0 again. So it's going to go. And what would it do after that? It would keep on repeating because these are periodic functions. So it's going to go. And then be another one of these asymptotes, and it'd go, where would that be? 90 on from So every 180. So what do we got? Would it be, have I drawn that asymptote at the wrong spot? 90, 180 plus that 180 is 450. I'll give it a greenie. And I'll just check it, tan 450. Undefined, beautiful. And then it's going to hit 0 again at 180, so 540. Let's just double check that. 10, 540, 0. Beautiful. So again, and it'll just keep going. So there's our function, but this time this function repeats every 180. See that bit? Those two bits, and then I get them again, again. So again, it's still a periodic function, but it's repeating every 180. Now, you can, and by the way, you can plot points for any function. You can use that method to plot points to graph any function. But we're going to play with some things. So I'm going to use Desmos for the next one. So I'm going to draw y equals 2 sine x. So we'll go back to Desmos and we'll go in here and I'm going to put a K there and I'm going to add a slider. I'm going to delete the cos curve so we can't see it. And let's see what happens when we play this slider. Where'd you go? It's up here. So let's play. Now, it looks to be stretching the curve up and down. Or you could say squashing it like an accordion. So it pushes in and then it pulls it out. So let's just stop it at 2. And move it along to positive 2. Now, what's happened? Well, if we zoom in, it's now gone up. Get back here. It's gone up as high as 2. All right, so if I play that a bit more, come on, play. Goes up to 10 and down. So that K does something to the sine curve. And this is what it does. It takes it up to 2. So it's going to be the same curve as this one, but it's going to go up to 2. Now, what were my points? 0, 180, 360. So we only want to draw it 0 to 360, and it's going to go up and down to 2. So let's put some points in. 0, 180, and 360. But it's going to go up to 2, which means it's going to go down here to negative 2. Now you can go and plot the points if you want, but you're going to get a curve like that. That first bit's a bit dodgy, I'll do it again. And there's my y equals sine 2x. It's the same curve, but it goes up to 2. All right, so if I put a 2 there, that's what that does. Let's go back to Desmos and have a look. If I take that K out of there and put it in here, and I'll shrink it down and we'll play this and see what happens. This is much more like an accordion. It doesn't increase its height, but it pushes it in and pushes it out. It pushes it in, and whereas the other one stretched it up high, this squeezes it. Okay, so what do we want to know? What it would be at about 2. Come on. And if I zoom in, now I don't know if you remember, but because it hasn't got degrees, 2, right, last time it went from 0 to 6 and a bit. Now we're getting 2 curves. 2 curves. Look between 0 and 6 on the positive x-axis, and you'll see to 6 and a bit you get 2 curves. So if I go back here, now again you can plot it. This time it's only going up to 1, but now I'm getting 2 curves. So I'm still going to get 0, 180 and 360, but instead of this, instead of 1 curve, I'm now going to get 2 curves. So I'll have to go something like this. So I'll just get rid of those and I'll draw it properly. So I'm going to get another one there and another one there. And I'm going to dot it so you can really see. It's going to go up to, oops, already I've got it wrong. I went above the 1. It only goes up to 1. So I'm going to zoom in a bit. Not that much so I can get the whole thing in. There. So I'm going to go up to 1, dot, 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 dot. Still only goes to 1, dot, 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 dot. I'm going to get 2 of them. So if I were to draw it properly, and does that look the same as the one I did on Desmos? Yes, it does. All right. Now, what about that? What has gone on there? Now, again, you can plot points, but remember, this number, what did it do? It stretched it up. And this number squashed it. So let's apply those 2 things. So now we're still going to have, well, we squashed it 0, 90, 180, 270, 360. They're going to be my zeros. And I'm going to squash 2 whole sine curves in there. But it's going to go up to 3. All right? So it's going to go all the way up and all the way down to -3. So I'm going to get a curve. I'm going to dot it. It looks like this. Let's put that in. Let's put an A in there, and we'll add that slider. And we've got 2, but our A is 3. And see if we're right. Come on. So, and look at that. And remember, we're looking to 0 to 6 and a bit. So you can see that it goes up to 3, and there's 1 curve, and it goes up to 3, and there's my second curve. All right. So that's about how you get it. Now, cos 3x. Well, we already know what this does. We already know that squashes it. All right? So we're going to get not 2 curves, but 3 curves in. And we know what this is going to do. It's going to shift it so it goes up and down between 2 and -2. And then you put them both together. It's going to squish 3 of them in and up and down to number -2. So the number in front of a trig ratio changes the height through which it passes. And I'm wondering, I'm just going to get my notes up. I don't wonder if I want to use the same words that I used before. The height, get out of here. So if I go to Desmos and I get it up, and you should be using the solutions as well. to make sure you're on the right track. I know what, yep, the height, and we on the y-axis, and we call that the amplitude. The number in front of the x, well, it changes, and I'm going to use the same words as the number of complete curves or functions. And we call that, and I already used the word, the period, how often it repeats itself. So that number tells you that it repeats itself. And these complete curves are between 0 and 360. All right, so use your Desmos book to help you with those last three, and use Desmos to have a look at them as well. All right, good luck.